Many people say we should use base 12. As it says on this Reddit post, Gizmodo and Science ABC, particularly for fractions and division, using fractions there, divide goods there. And then let's see if it's true. So now I'll be googling up why should we use base 12. You can skip to another point in the video if you want to skip past the benefits that Google says there are. And that's the Reddit post. Using base 12, also known as duodecimal, offers potential advantages over the current base 10 system, decimal, because 12 is divisible by no more numbers. This makes calculations, particularly involving fractions again, simpler and more efficient. Here's a more detailed breakdown of the benefits. More regular fractions. Base 12 allows for easier division into halves, thirds, quarters, and sixths without resorting to complex fractions and decimals. Simpler arithmetic. Operations like multiplication and division become more intuitive with base 12, especially when dealing with fractions and multiples. Historical usage, like a dozen, 12 inches and a foot, means it's practical. Grouping and organization, base 12 provides more flexibility in grouping objects because of more factors and potential for easier learning. Base 12 could lead to a more intuitive understanding of mathematical concepts for children. However, the main arguments against it would be habit and inertia, because we've used base 10 for thousands of years and we have 10 fingers on our hands. Digital technology means we might need a more fundamental shift to accommodate base 12, and lack of universal adoption would take a while for most people to use it. In summary, while base 12 offers potential benefits in terms of mathematical efficiency and the simplification of fractions, the ingrained use of base 10 in the technological landscape make a complete transition unlikely. But here comes the exciting part. I'm going to prove this by calculating the fractions from 1/2 to 1/25 in both base 10 and base 12. You can do this at home if you want, but I just use a calculator. Here's a very quick time-lapse of me doing it. I also published a longer video of me doing this, so you might want to watch that. It's very funny, and there's some things that you won't expect. I really recommend you watch that, but not right now. We have some more fractions to calculate, and I'll be finished. And now this is me doing it in base 12, and there's another time-lapse. This one was more standard. I've deleted the funny cuts for this one, sorry. But I'll be finished very soon. And thank you to Fulcrum Alpha. It's the only website that allowed me to calculate so many digits and find the repetitions. But this is not sponsored. It's the grand finale. I'm now going to add up the decimals and add up them for all the fractions. And let's see, which is better, base 10 or base 12? Base 10 has 320 digits. Base 12, 329 digits. It looks like base 10 is the winner, as you can see in my table. But hold on, base 12 isn't about the efficiency of fractions, it was about being easier, meaning more terminating decimals, which means decimals that stop. So I calculated decimals to 1/100 and manually checked if they terminated or not. And you can see I've added totals after every 25, those are in red. And now I have the 1 to 25, 25 to 50, 50 to 75, and you can see 8 versus 10, 11 versus 14, 12 versus 17. Base 12 is always in the lead. And the grander finale, good that you stuck on, 14 and 19. Base 12 is a lot better, about 35.7% better compared to 2.8% worse in the decimal round. But it's not that simple. Read the caveats that come up next to learn more. Base 12 would be in a larger multiplication table, but it would be more efficient and intuitive for learning it. Also, division would require that multiplication table, but less steps, as base 12 has more digits. And the next caveat is decimal to fraction conversions are only the beginning. Percentages would also be easier with base 12, while addition and subtraction and everything else would remain mostly the same. It would be difficult to transition to base 12, though it would be good. Last time on Recreating Mathematics, we checked if base 12 was better than base 10. Our results were a little bit difficult to understand because base 10 seemed better at first, but then we used a different measurement and base 12 seemed undeniably better. But is there something else? In this video, we're going to decide once and for all which is the best base. I'm now using a crazy method of comparison using the number of digits in decimals from 1/2 to 1/25 to find the best base. So this is what we made last time. a table for all the decimals, and I'm going to remove the ones that have a very long decimal expansion. Like 1/3 to 1/2 to 1/6, they're all pretty short. 1/6 has 4. And now 1/7 is pretty big, 6, which is 1 less than 7. That's the worst you can have. So I'm deleting 1/7. And now 1/11 and 1/12, they're all right. They're not very, very large. Now we have 1/13 and 1/14. I'll remove both of them. They're long 6-digit cycle. 1/17 is a very long one. Again, it's 16 digits of the period, which is 1 less than 17. It's the worst you can have. I think it's the same for 1/19. So off those two go. 1/21 is the same as 1/7, so it's still going. 1/23. Don't get me started on how long this monster is. But this is only in base 10. And this list is quite long. Now in base 12, 1/5, that's not that long compared to what we've been doing in base 10. It's 4 digits, which is 1 less than 5, so it's still the worst you can have. Deleting 1/7, 1/10, 1/13, not 1/13. That's alright, it's 2 digits. 1/14 is going in the bin, as is 1/15. Wow, they're getting slashed, the base 12. 1/17 is getting slashed. 1/19, 1/20, 1/21, all of them are long. Doesn't look very good for any of them. 1/23, I think it's a bit shorter than base 10. And 1/25 is a bit shorter as well, but still long. So I'll put these numbers here so we can do things with them. What things? Let's find out. Some things to notice. I could go on for ages about the amazingness of these decimals, but first, the divisors of 10, 2 and 5, and the powers of 2 like 2, 4, 8, 16, and the powers of 5 like 5 and 25, all of them have terminating in relatively short decimals. There is another aspect to this, but let's just keep it there for now. For base 12, the same is true. Its divisors 2 and 3, prime divisors I should say, and the powers like 3 and 9 and 2, 4, 8, 16, those all are terminating and short. In fact, I should say most multiples of 2 and 5 for base 10, and also for base 12, 2 and 3 are there. Like for 2, we have 2, 4, 6, 8, 10, 12, and then 16, 18, 22, and 24, and 20. So we're only missing 14. In fact, there are no multiples of 7 in the base 10 or the base 12 ones. They're all gone. And also check 11 and 9 for base 10 and 11 and 13 for base 12. Those two border 10 and 12, but those two do not divide by 10 or 12, but they are still short. There's a reason for this, and let's move on to that. This will be essential for not only giving us the most divisors, but also giving us the least amount of decimal places because of these special 9 and 11s. Also, the multiple of 9, 18, and divisor of 9, 3 work. 11 times 2, 22, that also works. Let me prove the second bullet point now. So, if you have any base and you square it and subtract 1, according to the difference of squares, that would be the base minus 1 times the base plus 1. And you know that 0.9999 is equal to 1. So if you keep repeating those, you're going to get 0.99999 in the base. So there we go. That's proven. Okay, so let's check which base has the most prime factors for n minus 1, n, and n plus 1, n being the base. But keep it under base 16 or hexadecimal because after that, counting gets ridiculous. The grand finale 2. You'll understand soon. The best base is base 14 because it has 5 factors from 13, 14, and 15. 2, 3, 5, 7, and 13, and the smaller the more frequently they appear. So these are small, and that's good. So base 14 is the perfect base. It doesn't make counting ridiculous, and it makes decimals easier. Well done, base 14. But it has 369 digits, and it doesn't beat the 320 in base 10. but it did base 15 for reasons I won't get into, and that beats it with 309 digits. 15 is more familiar than 14. It is a multiple of the numbers of fingers on a hand, and is good for similar reasons to base 14, so let's grow another hand and use base 15. Fun fact, the first number to beat 14 in the factor is 34, with 6 prime factors, but of course counting it's ridiculous. Thank you for watching, and this is the end. Don't forget to like, comment, share, and subscribe. Bye. Thank you.